You know, when you're looking at a massive video wall at a sports bar, or maybe watching a live concert broadcast, you just kind of assume the video and the audio perfectly match up, like the explosion happens on screen and you hear it the exact same millisecond.
Right. It feels automatic. I mean, we take that flawless synchronization completely for granted.
Welcome to today's deep dive. We are looking at the hidden engineering that keeps that illusion alive, using specs from HDTV Supply's AJA GEN Sync Generator. It's basically a $1,200 piece of metal that stops your favorite broadcast from turning into, well, an unwatchable mess.
Yeah.
Okay, let's unpack this.
Yeah, it really is a critical piece of gear. And, the precision required to pull that off is just staggering.
So to understand why a tiny, 5.8-inch box costs over $1,000, think of a massive AV setup like a series of giant gear wheels. You have one spinning for your video feeds and another for your audio. And if one wheel spins even a millimeter faster than the other, the teeth grind and the whole system jams. So this AJA box acts as the central drive shaft, keeping both gears locked at the exact same RPM. How exactly does it do that?
Well, what's fascinating here is how it keeps them locked. It relies on what's called a master time base. This isn't just your standard clock,
Yeah.
It's an incredibly precise internal timing mechanism, boasting an accuracy of 3 ppm or 3 parts per million.
Wait, which means what, practically speaking? Like, if a clock is off by a few fractions of a second over an hour, does everything really fall apart?
Oh, absolutely. Because video and audio are processed independently by different pieces of gear.
Yeah.
If your master clock drifts even slightly, within an hour, your video will start playing frames ahead of your audio.
Oh, wow. So suddenly you're watching a terrible lip-sync dub.
Exactly. That 3 ppm accuracy ensures the synchronization doesn't drift at all, keeping those gears turning perfectly together over long, continuous broadcasts.
And it's doing this across 7 simultaneous outputs, right? It's generating standard definition references like color black or bars, which basically give older cameras a baseline signal to lock onto.
Yeah, alongside 19 different HD formats like 1080p. Plus, it outputs a dedicated AES 11 signal.
What is AES 11 exactly?
Think of it as a specialized digital metronome strictly for your audio equipment. It guarantees the sound matches those video frames perfectly.
So because it has all these different outputs built in, it can run the entire system directly. I mean, you don't need to buy a separate sync DA, right?
A sync distribution amplifier. You don't need one just to split the timing signal to all your different cameras and audio mixers. It handles that distribution entirely internally.
But here's where it gets really interesting. You have that level of complex, high-tech engineering, but it introduces a really weird paradox when you actually look at the physical device.
You mean the dip switches?
Yes. Looking at the user reviews on the site, this is where the friction happens. You have this near-perfect mathematical synchronization, but to change settings, you are literally flipping tiny physical toggles on the back of the box.
It definitely feels like a relic from another era.
Totally. Users are complaining about having to physically walk over and reboot connected matrix gear. One review specifically wished they could just manage it all from an iPad app, and there's even a 1-star review just complaining about a 10-day wait for out-of-stock gear. I struggle to accept this reliance on old hardware, honestly.
How so?
Well, we run global banking and air traffic control on software. The idea that a high-end sports bar video wall requires a physical toggle switch from 1995 just to avoid a system crash, it feels like the professional AV industry is simply refusing to adapt to modern technology.
I see your point. But if we connect this to the bigger picture, it's not about refusing to adapt.
No.
No, it's about the brutal reality of live broadcast environments. A system crash during a packed Sunday football game is catastrophic. Physical switches, like those dip switches, can't be hacked.
I guess that makes sense.
Yeah, they don't lose their Wi-Fi connection, and they don't suddenly force an unexpected firmware update right before kickoff.
So it's a deliberate choice. You're prioritizing absolute survival over user experience. You want a hardwired connection that cannot fail, rather than a sleek Bluetooth interface that might randomly drop out.
Precisely. The annoyance of having to walk over to an equipment rack and flip a physical switch is a very small price to pay.
Yeah.
It is the absolute guarantee that your signal won't go down. In broadcast, reliability always trumps convenience.
That is really something to think about. So the next time you're sitting at that sports bar and you look up at a perfectly synchronized massive wall of screens, you'll know it's not just magic.
Yeah, there's a dedicated physical drive shaft working tirelessly behind the scenes to keep all those digital gears locked perfectly together.
Exactly.
Which raises an important question for you to ponder. As our displays and audio systems become increasingly networked, software-driven, and wirelessly connected, will the need for a physical, hardwired master time base eventually become obsolete?
Right, that's the big question.
Or, no matter how advanced our networks get, will we always need a physical anchor to keep our digital world from descending into chaos?